Hey, Mr. Ben.
Hey, how you doing, Mr. Baldwin?
Not too bad. All right, so talking about soil some more.
Okay, are soils the same throughout the United States?
A lot of people think that soil is soil is soil is soil, but there's lots and lots of different types of soils. There's
Okay.
actually a couple hundred different types of soils that, just like we have different types of fish, like we have different types of clams and oysters, there's all kinds of different soils too.
Wow, probably has to do with the minerals and things that are in it.
It has to do with all kinds of different things that we're going to talk about here.
We got to make this easier for the kids. Can we limit it down to maybe just a couple types?
Start with two.
Okay.
Okay, across America, United States, there's two major types of soil. They dominate. Oh, sorry, you guys got to be at packet page 21.
Ooh, on the bottom.
Yeah, we're bouncing around a couple times on your slides, so just pay attention. We'll tell you what packet page or if you need to write stuff down. Okay, so very generally, two major soil types in America. Towards the eastern half, what do we got?
We have a lot of rain, and we have pedal firs.
Pedalfers, yeah, absolutely. And then in the western half, we got what are called pedal-cal soils.
Not as much rain.
Not as much rain. It's much drier out there, and there's not as much weathering that's going on over there. Because remember from the rates of weathering video, talked about more water is going to make things weather faster.
Chemical.
Yep. And so if you're drier, it's not going to weather as fast.
And more mechanical.
There you go.
All right. So it looks like they're hiding like words within the names. Like ped has to do with like podiatrist. That's your foot, right?
Yep.
So soil's down by the feet, and there's Al. Isn't that an element?
Aluminum.
Okay. And Fe in the fur, that's like ferric.
Ferric, which is iron.
Okay. So those soils on the eastern part of the United States must have a lot of iron and aluminum washed, alluviated down into the soil.
Yep. And then if you go out west, you've got more calcite. Okay?
Oh, that must be where it gets hot, water evaporates, and the calcium only goes so far, and it just makes it really hard like pan.
Yeah, and actually there's some layers out there where if you try to dig through them, the calcite's so hard, it's almost like concrete down there.
I think they call it hard pan.
Yeah, it's pretty cool. One of the ways I remember it, California's out west, pedo-cal.
Oh, that makes sense,
There you
Cal.
go.
The cal's for the calcium or the calcite.
Perfect. Okay, so those are the two main types that we see. And again, there's hundreds of types of soils, two main types in America.
All right.
Okay, so we already talked a little bit about it, how water can affect the soil development. But can other things kind of influence soil development as well?
Definitely. I think there's a list like times in there. We've got parent material. We've got climate and moisture. Those are the big...
Yeah.
Oh, temperature. Yeah.
Temperature, yeah. Okay. So if we looked at soil moisture, when we combined it with the differences in the parent material and the organic material,
Right.
okay, that's going to really influence the type of soil that we have.
Okay. So what the material is that's underneath, you said like the R horizon, what's there that's breaking down, making the regolith, that's going to be a big determiner of the type of soil. And the vegetation that grows on top that dies, its acids and stuff, how that combines with the regolith is going to be the other determiner for the soil.
Yeah, and like say if we start with a granite in one place, it's going to be a much different soil, as if we have like say a basalt. And it's two different things you're starting with, so your end product is probably going to look a lot different.
All right, because your parent material is different, so your soil is going to reflect what your parent material looked like, since a lot of your soil is from the parent material.
Absolutely. Yep. Okay, so back to page 20, actually. We're jumping back, so you have to flip over one page, going back to packet page 20. So we just talked about before that different things can affect the type of soil you have. So like we were talking about water. And we were talking earlier that acid rain, because rain can be acidic sometimes when you get some pollution in the atmosphere, it can really affect the soil. It can wash through, and we talked about that word leaching.
Right.
The acidic rain can actually increase leaching.
Okay.
And those clays that really hold on to a lot of these different nutrients, they can't hold on to those nutrients anymore. And they wash right out of the soil.
So the acids kind of grab some of those charged ions, those metallic ions, cations, and pull them down?
Yep.
I bet the trees that are weak and like the old trees are probably the ones that, baby trees, old trees, weak trees, they're going to show first signs of like this kind of weakness.
Yeah, they're going to be the first ones that are damaged. And usually they get attacked by bugs real quick, or you can see at the bottom they break, like the branches break under snowfall.
Mm-hmm.
And so the increase in acidity is going to change that soil chemistry by leaching out those elements, and it's going to make those weaker trees even weaker.
And when you say increase in acidity, it's actually a smaller number, but the acidity is increasing.
Yeah.
So you're drifting from your 7 down towards maybe your 3 or 4.
Yeah, absolutely.
All right. There's a lot to know about soils.
Oh my gosh, you better believe it. This is just the tip of the iceberg.
So we flip back to page 22.
22.
Okay.
Okay.
Laterites. That's a soil that's kind of red, isn't it?
Yeah, usually it turns out kind of red. If you ever go kind of down towards around the equator-ish, we'll talk about where you see a lot of them. But there's actually a lot of water by the tropics, right?
Right. Lots of rain.
Okay, and that's actually because you're in a tropical environment, rains a bunch, and you end up getting a lot of leaching taking place. You're washing away a lot of these different chemicals, or sorry, the nutrients out of your soil.
So the water molecule is able to grab a lot of those cations, so a lot of those metals and such that are in the soil and pull it down.
Yeah.
Probably some get left above, like the red, like the iron get kind of left above, and it gives it that reddish color. And the other cations, the other things, get leached or pulled down. Okay.
So like we said, laterite soils, they dominantly form in tropic environments.
Right.
And they actually form really thin layers on the rainforest soil. Okay? There's not much soil in a rainforest. A lot of people think rainforest, a lot of biodiversity, really big plants, gotta have good soil. It's actually not very good soil. It's really poor soil over there.
Yeah, I've heard most of the wealth of the soil is actually in the organic stuff in the top.
It's all locked in organic matter, yeah.
That must be why those people sometimes burn the forest to get all that on the soil, and then they quickly plant for a couple of years and they can grow.
Yeah.
And then it rains a lot and all that good stuff washes away.
Yeah, it's not really good for supporting agriculture. They call it slash and burn agriculture. And it only lasts, you can only support yourself for a few years, and then you've basically cut down a whole rainforest for about 2 years worth of profit.
And then it doesn't grow back overnight. Okay.
And that organic material, what happens is as the trees grow, plants grow, when they die, they fall back to the ground, and they start forming that really thin O layer, that humus. So you get a big accumulation of humus on the forest floors. Okay, and then the hot and wet conditions, they increase that chemical weathering. So you end up getting a lot of weathering taking place because it's so hot, so humid. Okay, and then those nutrients, the reason why the nutrients are so easily leached is because they're easily taken up by the plants.
Right, so the plants look good because they're pulling that nutrient, so the wealth of the soil is actually in the vegetation. And it's not until they burn it that those minerals and cations and things that would make the soil really healthy go into the soil.
Yep, and if you cut down the vegetation, it leaches right all away your nutrients.
So all those good things for the soil are taken away, and you're left with like parent material, a lot of iron.
Yep. All right, let's keep going. We'll show a quick map of where we find these laterites because they're pretty important. And you find them really around your tropics.
Okay.
Okay, so you got them, not many in North America, a little bit through Mexico, South America. And really, if you're looking at your biomes or your different environments, you're looking in your rainforest, tropical rainforest, right around your equator.
Right.
That's all I got about that one.
Yeah, I just think of some of the pictures I've seen in South America and Africa showing those kind of red soils. That must be these laterites. And Asia.
All right, last one we got here. We're talking about clay. So we said clay was the smallest of those three particles. Remember we had sand, silt, and clay. Clay was super small, microscopic in size.
Yeah, less than 1/256 of a millimeter.
It's ridiculous. I could never try and measure that with a ruler.
No way.
Okay? So, they're really small, but they're really important for plant growth because they hold a lot of these nutrients for us.
Okay, they probably are charged.
Yeah, and they actually have a positive charge. So surface layer of the clay minerals have a positive charge.
Okay.
And what happens, because we said in one of the earlier slideshows that water's polar.
Right.
So it's got a positive end and negative end. That negative end is going to be attracted to the positive end. Okay? And you actually get clays that kind of suck in water. They soak it in really well.
So you have a layer, and that water molecule comes down, and then the oxygen end, which is a negative end, kind of sticks to it and accumulates the water, kind of builds it up on it. That's why water kind of piles up on top of clay.
Yeah, if anybody has problems with flooding in their backyard, a lot of times it's because their soils are really high in clay, and the soil just acts as a big sponge and just soaks it up.
Okay, interesting.
So that would be where if we had a lot of chemical weathering taking place, you might have a lot of clays present.
Oh, because like you break down feldspars from your granite and you get clay. Clay accumulates and water's going to kind of accumulate with that.
Absolutely, yeah.
It all connects.
And what's kind of cool, even throw it back to our minerals, mineral resources, that's one of the reasons why moisturizers and beauty products have a lot of clay in it, because they hold the moisture really well.
Ah, they should call it oil of old clay.
That's awesome. Well, that's all we got for you guys today. Go back to your class website, and you guys got a quick mastery quiz.
All right, see you later.
Bye, guys.